Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we are going to discuss about soil moisture irrigation relationship. So basically, in this video, we are going to discuss about the various type of moisture level that are present in the soil, and at what moisture level should we go for the irrigation. All right, so let us start with a basic introduction. So we all know that the soil resides over an impervious strata. So over an impervious strata, there is a depth of soil available. Now, the water below which the water table is available is called as the groundwater. We have the impervious rock strata over which we have, let's say, d depth of soil, and here to a certain depth there is the water table. So the water that is available, below the water table is called as the groundwater. So the soil will be at a saturated state in this depth. Above groundwater, there will be certain amount of moisture available in the soil, and this moisture will be used by the plants or by the crops for their growth. Now, to extract the soil moisture that is available in the soil, the plants will use their root to extract that amount of moisture. So the depth up to which the roots of the plant go is called as the soil zone or the root zone. So the depth up to which the roots of the plant go is called as the root zone, and in this root zone the plant extract the moisture for their growth. Now, above groundwater table, there will be certain rise in water because of the capillary action. Because of the capillary action, the water will rise. So where the phenomena is very prominent, the depth up to which this phenomena is very prominent will be called as the capillary zone, and the depth in between root zone and capillary zone is called as the intermediate zone, and the combination of root zone, intermediate zone and capillary zone is the soil moisture available in the soil. Now this soil moisture that is available in the soil, that is present because of the intermolecular force in between the soil particle. This is the soil moisture that will be extracted by the plant for their growth. So we are going to discuss about the overall moisture content of this zone only. So the moisture content can be divided into like three sections. So the first one is the gravity water or the surplus water. Then we have the available moisture content, also called as the capillary water, and after this we have the hygroscopic water or non-available moisture content. Now let us discuss about these three in detail. First of all, we have the gravity water or the surplus water. Now the gravity water or surplus water is the excess quantity of water which will drain off under the action of gravity if free drainage is allowed. To better understand with the help of example, at any point of your lifetime, I believe you must have watered your plants in the garden. In your garden, you must have plants which you have watered. Now, if you keep on watering the plant, if you provide some excess quantity of water in the plant, you must have observed that the excess quantity of water drains out from the bottom of the pot. Now this excess quantity of water that drains out, this drainage is under the action of gravity, right? This is the surplus quantity of water that was provided by you. So this drains out. Now this excess quantity of water is what we call as the gravity water. Okay. Then we have the available moisture content or capillary water. So there will be certain water that will be retained by the soil. There will be certain moisture water content or the moisture content that will be retained by the soil, and this water will be used by the plant for their growth. So this is the available moisture content, or capillary water is the water content that is available in the soil and will be used by the plant for their growth. And the third is the hygroscopic water, and hygroscopic water is also called as the non-available moisture content, and as the name suggests, it is the very small amount of moisture content available in the soil that is of no use, that contributes nothing towards the growth of the plant. So your hygroscopic water is like you take a sample of the soil, you put it in the oven, you get it oven dry, lose every molecule of water from the soil, and then you put it in the room temperature. So that oven dried soil will absorb very small amount of moisture from the atmosphere. That is what the hygroscopic water is. Okay, so we have the gravity water, also called as the surplus water. We have the available moisture content or capillary water, and the third is the hygroscopic water or non-available moisture content. So the combination of available moisture content and hygroscopic water is what we call as the field capacity. Okay, so this field capacity is the overall moisture content minus the gravity water, or in another term we can say field capacity is the available moisture content plus hygroscopic water. So this is the overall moisture content that is there in the soil. So this is the upper limit of the field capacity. Next level is the wilting point, denoted by phi. Field capacity is denoted by Fc, wilting point is denoted by phi. Now wilting point is that moisture level in the soil that if the moisture content goes below the wilting point, the plant or the crop will like perish, they will cease to exist, they will become dead. Okay, so the wilting point is that moisture content below which, if the moisture content goes below the wilting point, the crop will die. So in between the field capacity and the wilting point, this is the range, and in between this lies the optimum moisture content. Now this optimum moisture content is the desirable moisture content that we want in a soil for the growth of a particular crop. Now this optimum moisture content will depending upon the type of plant or type of crop that has been sown or grown, it will depend upon that. The optimum moisture content for a specific crop can be here, the optimum moisture content can be here or can be here, right? But it will lie between the field capacity and the wilting point. Now the range between the field capacity and the optimum moisture content, this range is called as the readily available moisture content. This amount of moisture content is easily available for the plant to extract from the soil. Alright, so just for a quick revision, your gravity water is the portion of water that can be removed by the action of gravity from the soil sample. Then we have the field capacity. Field capacity, it is the water content in the soil after free drainage has taken place. So like we discussed, free capacity is the combination of available moisture content and hygroscopic water, or from the overall moisture content minus the gravity water, right? So this field capacity is made with the combination of these two. So the field capacity can be described as the ratio of weight of water retained in a certain volume of soil divided by the weight of same volume of dry soil. The readily available moisture is the portion of the available moisture content which is most easily extracted by the plant and is around 75 to 80% of the available moisture content. Okay, so this readily available moisture content we have discussed. This portion of between the field capacity and optimum moisture content, like it's very easy for the plant or for the crops to extract this moisture content. Then we have the permanent wilting point, and permanent wilting point is the water content at which plant can no longer extract the sufficient amount of water to sustain its growth, and the plant will eventually die up, because hygroscopic water is very minuscule amount of moisture content in the soil. Then we another term that is there is called as the saturation capacity, and saturation capacity is like the level of the maximum moisture content that is present in the soil. So at the moisture content below the water table, this soil will be in the saturated state, and this is the maximum amount of moisture that the soil can hold, and this is called as the saturation capacity. The next term that is there is the soil moisture deficiency, and it is the water required to bring the soil water content of a given soil to its field capacity so that the crops don't wither out. And there is the another term called as equivalent moisture content, and it is just like the field capacity, and field capacity is like the water retained by a saturated soil after being acted upon the gravity. So like your equivalent moisture content is like the overall moisture content minus the gravity water. Your equivalent moisture content is it is same thing, except instead of gravity the water is drained out because of the centrifugal force application acted for the 30 minutes. So after that if the water is allowed to drain, and after that whatever water is remained, that we refer to as the equivalent moisture content. Now we have discussed about the available moisture content, we have discussed about the readily available moisture content, we have discussed about the field capacity, we have discussed about the optimum moisture content and the permanent wilting point. Now let's correlate this with the growth rate of the plant or growth rate of the crop. Now we have discussed about the field capacity and optimum moisture content, and the range in between these is called as the readily available moisture content. So if our moisture content of the soil is within this range, the moisture content is the readily available moisture content, then our plant will sustain its growth. It will grow in a very steady pace, in a healthy manner. If the water content goes below the optimum moisture content and above the permanent wilting point, right? If the if you are in this zone, that is the moisture content has gone down the optimum moisture content, but it is above the permanent wilting point. So the plant will start to wither out. You can visualize it by considering the scenario, like if you regularly water your plant, then it remain healthy. Now if you skip 2 to 3 days or 4 days or 5 days, you will observe that the plant starts to dry out. and after 5 days, let's say, uh, you again water your plant, it will again regain its natural state. So the plant at this stage has not completely dried out, but it starts to wilt up. It's not completely dead, but if you go beyond 5 days or 6 days, it will be completely dead. So this state is what this region of the graph represent, that is optimum moisture content minus the wilting point will give you the withering stage of the plant. Okay, so this is the at this stage the plant doesn't have to work too hard to extract the moisture content and work too hard to maintain its sustenance. There is ample amount of water that is available and the growth of the plant is sustained. While here, when the moisture of the soil goes below the optimum moisture content, then the withering of the plant starts to take place, and it will, as the moisture content goes below the permanent wilting point, the plant is completely dead, because there is no moisture in the soil to extract for the plant and to sustain its growth, right? Or otherwise, in between this range is there, then we after certain moisture is applied, the water level will again reach to optimum moisture content and the plant will sustain. So we have the available moisture content Fc minus 5, readily available moisture content Fc minus m naught, right? M naught is the readily available moisture content. We have discussed about this just now, so I hope the concept is clear to you all. Okay, so on and all, if we talk about the frequency of irrigation, so if we talk about the moisture available in the soil, we have the wilting point, we have the optimum moisture content, and we have the field capacity. So the frequency of the irrigation should be that we have applied the water, the moisture of the soil is at the field capacity, right? And this was the first watering that was done, and the soil the available moisture content of the soil is at the field capacity. Now, at what interval should the second watering should be done? At what interval the second watering should be done in the soil? So after a certain period of time, the field capacity, the moisture content of the soil will start to decrease. The crops will be there, the plants will be there, they will consume the moisture, and the moisture content of the soil will decrease. So as soon as the moisture content of the soil reaches the optimum moisture content level, at this point we should do the second watering. By doing so, the moisture content of the soil will again reach back to the field capacity level. Okay, and then again the third word, again we skip few days for few days, and then the moisture content of the soil will start to go back to these optimum moisture content level, and then again third watering shall be done to increase the moisture content of the soil back to the field capacity. And then this is how the interval of irrigation is decided. In no condition we want our moisture content of the soil to reach at the wilting point, because if we delay, let's say if we would have skipped the second watering interval, so what would have happened after this point? It would have further gone down, the moisture content of the soil would have further gone down and would have reached the permanent wilting point position, and at this point the crops would have died, and no matter after that how much water we apply and reach back to the field capacity, it doesn't matter, because the crops has already died. And even in the case if we would have done the second watering before, like not exactly at the wilting point, if we would have gone here, then the yield of the crop would have decreased, or the growth of the plant would have decreased, right? So it is very vital to understand this soil moisture irrigation relationship. Having knowledge of that, having knowledge of this soil moisture irrigation relationship helps us to understand the frequency of irrigation that is to be required for a particular soil with respect to the crop that is sown on the soil, so that the maximum yield of the crop can be achieved, or the maximum growth of the plant can be achieved. Okay, so I hope the lecture was clear to you. This was all for today. Thank you for watching, and if this lecture was informative to you, make sure you like the video, and consider subscribing to the channel for more videos like this, and press the bell icon for regular notification. And do share your views in the comment section, like what improvement can be you are looking for in the lecture, or is there some specific topic in the irrigation engineering or any other civil engineering topic that you want me to prepare lecture on. Okay, so thank you for giving your time, and thank you for watching. Have a nice day.